Okay, now we're moving on to integration of more complex functions. All the previous functions were relatively straightforward. These functions have complexities to them. The general template that we're going to have for these functions is, will be, if we're integrating a function like ax plus b to the power of n with respect to x, then what we'll end up having is the resultant function will be ax plus b to the power of n plus 1 all over a times n plus 1 plus c. Okay, that's the basic template of what we're following for all of these exercises here. In question 1 of exercise 3.5, what you'll find is that they're all indefinite integrals, so we'll always have a plus c. And in question 2, they're all definite integrals. They're all definite, so we'll have boundaries of integration, and we need to evaluate what we get there, and the c is of no consequence to us when we're doing those integrations. So here's the important template that we want to follow as we work through all of this particular exercise. Right, let's get started. We're in exercise 3.5. And we're going to be starting on question 1c, right? And it asks us to find the indefinite integral of 5x minus 1 in brackets to the power of 9 with respect to x. Now if we follow this template here, here's our function in the brackets to a power, and we're just going to end up pretty much copying out this, but instead of having the pronumerals of a and b and n, we'll put in the numerals, and we'll have the appropriate numerals in our answer. So following that template, we'll end up having 5x minus 1 to the power of 9 plus 1, which is 10, all over. The value of a in this expression is 5, so we'll put 5 down in the numerator, and the value of n plus 1 is 10, so we'll multiply that by 10, and then we'll have plus c. And if you would like, then you could write this out as 5x minus 1 to the power of 10 over 50 plus c. That's probably how the textbook would have its solutions written, and so that you could check your answers. 1c, straightforward. It's a recipe, it's a pattern, or actually in mathematical terms, it's an algorithm that we're following, and that's how it works. Part E, question 1, part E. Let's have a go at that one. We've got the integral of 4 plus 3x to the power of 4 with respect to x. We just follow the template again, follow this template. In this case, we'll see that in the brackets we've got 4 plus 3x, and n's value is 4, so we go 4 plus 1, which is 5. The value of a is 3, so we'll have 3 times 5, and then plus c. Again, in the textbook, the solution will probably be 4 plus 3x to the power of 5 all over 15 plus c. Probably that's how it's got. And that's tidier, it's neater, but it's no more correct than what we have there. But probably we should work towards that. I'll let you do that when you do these exercises. For part J, we get an added layer of complexity here. We're finding the indefinite integral of 2 outside of 3x plus 1 to the power of minus 4 dx. So again, a couple of points of discussion here. One is that this is a constant multiplier, and sometimes it can just be easier to deal with the whole process if we take constant multipliers out in front of the integral sign. So let's do that. We'll end up having 2 outside the integral of 3x plus 1 to the power of minus 4 with respect to x. And now for the final bit, we would just, again, follow this template, follow this algorithm, and we'll get that our answer is, sorry that it doesn't all flow on beautifully there, but you'll still get the same result, even though it's gone to the top of the board here. It'll be 2 times, let's put this in square brackets just so it clearly separates things out. it'll be 3x plus 1 to the power of minus 4 plus 1 will be minus 3. The value of a in this case is 3. That's the coefficient of the x term. So we'll put 3 here times, and this power now is minus 3. So we put that minus 3 here. Okay, and then we'll put the plus c inside the square brackets this time, but ultimately where the plus c goes doesn't make a big difference. And we'll have now, if I do write this out to completion, we'll have 2 outside of 3x plus 1 to the power minus 3 all over minus 9 plus 2 times a constant is still a constant. Sometimes you'll find that the constants are given a subscript to denote that they are slightly different in value, but they're still constants regardless. And what you'll probably find is in the textbook, the answer will be written as minus 2 over 9, 3x plus 1 to the power of 3. I don't know for sure about that, but it's probably how they'll have that answer written. Alright, working with index forms and also take the constant out the front of the integral sign helps us work through things with a little bit more ease. Example K, or question K, wants us to find the indefinite integral of 1 over 2 outside of 4x minus 5 to the power of 3 dx. This 1 over 2 is really, it's a half. 1 over 2 is a half. So it could be written as the indefinite integral of a half times 1 over 4x minus 5 to the power of 3 dx. Could be written like that. And we could take this constant out the front. I'm going to work ahead without doing that. And the result will be the integral of a half. We want to change this into index form. So we're integrating 4x minus 5 to the power of minus 3 with respect to x. And now we follow this template. We'll have 1 half 4x minus 5 to the power of minus 2 all over the value of a here is the coefficient of x is 4, so we'll have 4 times minus 2 and then plus a c term. And if we bring all of this together, then we'll end up with, I'm going to let you work through the algebra as to what the final answer is going to look like. If you're not sure how I get from this line to the next line, you just work steadily, one little step at a time through the algebra to get from here to where we end up. But that's, I'm going to leave that to you. We'll have 1 over 2 times 4 is 8 times 2 is 16. 16, 4x minus 5 to the power of 2 plus c. And because of that negative sign there, actually this fraction is a negative. So we'll just put a negative out the front. So it shows that this whole fraction is a negative and then plus c. All right, last example from question 1 is n.